Every morning, billions of people wake up and interact with a highly curated version of civilization. We picture the objects immediately in front of us: the polished glass of a smartphone, the steering wheel of a car, or the seamless interface of a delivery app. Pushing past that glass reveals a different landscape. Down here, at the microscopic level, we find a sprawling metropolis of silicon circuitry. Every text message, financial transaction, and satellite navigation request routes through these tiny channels. Building something at this scale requires an industrial apparatus of staggering complexity, a network operating entirely out of view. The logos stamped on the back of our devices represent a fraction of the story. Our way of life is sustained by a hidden class of industrial giants, an interconnected global megamachine quietly keeping the modern world alive. To understand this system, we have to look at how that silicon brain is actually built. The process requires extreme ultraviolet lithography, a technique that uses tightly controlled wavelengths of light to pattern nanoscale features onto a silicon wafer. The equipment that performs this task is built by a Dutch company named ASML. Behind the clean exterior of their multi-million-dollar machines is a dense thicket of metallic wiring, vacuum chambers, and precision optics. It is arguably the most complicated piece of manufacturing equipment humans have ever designed, and it cannot operate in a normal room. A machine this precise requires absolute perfection from its surrounding environment, isolated from the slightest vibration or microscopic particle of dust. Companies like TSMC construct sprawling fabrication plants simply to house these machines. These facilities cover immense tracts of land and require their own dedicated power substations and water treatment networks. To carve patterns measured in atoms, we had to build physical structures measured in square miles. Creating the smallest components of our digital lives demands the largest physical manufacturing environments ever constructed. We usually think of a factory as a building filled with individual tools. At the highest levels of industrial manufacturing, however, the entire factory operates as a single, fully integrated machine. The physical muscles of this ecosystem are programmable robotic arms. Companies like KUKA supply these specialized units to perform high-speed, repetitive automation with flawless consistency. These advanced systems can independently orient and assemble heavy engine blocks, handling intense physical loads without human intervention. But an industrial robot doesn't simply appear. The steel joints, actuators, and precision sensors inside every robotic arm were cut and shaped by separate machine tools, heavy equipment specifically designed to shape industrial metal. Industrial civilization is circular. We are reliant on factories equipped with machines, which were built to manufacture the very machines that assemble our everyday products. Assembling these components is only half the equation. A robotic arm built in Germany and a semiconductor fabricated in Taiwan must physically travel thousands of miles to interact on the same assembly line. That distance is bridged by a global logistics network. Automated terminals use enormous ship-to-shore cranes as physical routers, continuously sorting millions of steel shipping containers. These containers are loaded onto flutes of colossal vessels, operated by giants like Maersk, moving immense physical cargo across the oceans 24 hours a day. Distance has been conquered by a continuous planetary conveyor belt. This logistical web effectively turns the globe into a single, interconnected factory floor. Tracing the cargo on those ships back to its starting point, we eventually run out of assembly lines. Everything digital begins as raw earth. Extracting base elements like iron, copper, and lithium requires colossal earth-moving machinery. These excavators and articulated haulers bite directly into the planet's crust, pulling up the raw chemical elements necessary for every battery and microchip. Digging up those metals, smelting them, forging the robotic arms, and powering the server farms creates a constant, massive demand for electricity. To meet that demand, companies build massive mechanical generators. These precision-engineered turbines spin at incredible speeds, converting physical force into electricity, powering the entire chain. Our seemingly clean, wireless digital existence is dependent on continuously ripping open the earth and burning astronomical amounts of raw energy. This deep interdependence raises a critical question. What happens when a system this hyper-connected encounters a failure? Countless consumer brands rest on a narrow foundation, relying on a handful of industrial monopolies controlling the global economy. Companies like ASML, TSMC, Maersk, and Siemens. If a disruption hits just one bottleneck, the impact cascades upward, paralyzing the consumer brands above. The global system's greatest strength is its hyper-specialized efficiency, but that exact same efficiency is also its most dangerous vulnerability. We are now pushing this infrastructure to its limits with the expansion of artificial intelligence. It is easy to imagine AI as weightless software, a quiet algorithm floating in the cloud. In reality, AI is grounded in concrete and steel. Training these models requires endless rows of heavy servers, massive liquid cooling systems, and an enormous, continuous draw from the electrical grid. AI functions as a new layer of industrial infrastructure, compounding the demand for the chips, power, and cooling systems we've already explored. It is an extension of the physical machinery that sustains civilization. When we look back at the illuminated city at night, the view is different. These lights represent the visible exhaust of the global megamachine. Every glow is the output of the turbines, chips, and mines operating in the background. Modern civilization is no longer a collection of separate human tools or disconnected consumer products. We have built an integrated ecosystem. Humanity now lives inside a single, self-sustaining, planetary-scale machine made of millions of interconnected machines.